I'm going to start with a couple quotes. One is by Euripides. He was a Greek playwright, okay? And this is what he had to say, which I think is pertinent today for what we're going to be talking about. It says, if you bring novel wisdom to fools, you will be regarded as useless, not wise. And if mathematical physics regards you as greater than those with a reputation for cleverness, you will be dismissed as a crank. Not the exact words that Euripides pronounced, but I think that's pretty close. And a few hundred years later, we have this fellow, his name is Galileo, and he said something similar. He says, in time you may discover everything that can be discovered, and still your progress will only be progress away from humanity. That's interesting. The distance between you and them can one day become so great that your joyous cry over some new gain could be answered by a universal shriek of horror. Yeah, I feel for them. I know what they felt because, I felt it in my own skin. And, I have a different saying that I like to use out there, and that's this one. Can't beat them, ridicule them. So that's what I do. I try to ridicule these people because they are ridiculous. Their ideas, the explanations they have for how this universe runs at the microscopic level, at the universal level, and we're talking about not only general relativity and quantum mechanics, but you're talking about string theory as well, which is trying to merge the two. It's unmergeable, and they never discovered that, but someday maybe they will. Who knows? Anyways, you say, well, Bill, why should you ridicule them? Shouldn't you treat them nicely? Don't they deserve some respect? Well, yeah, when I came out with my theory, I was surprised. I thought the world out there was scientific, and I had this notion that, in science you present your ideas, people listen, say, well, I don't like your idea. That's fine, no problem. But when you're not even allowed to present your idea, when you have a different idea, right? And on top of that, they throw rotten tomatoes in your face. Well, then at some point, a lot of people start rebelling against that. And you might say, well, should I be wearing a tin cap over my head or whatever? No, it's not an issue of that. It's that, people have always criticized those with different ideas. And once you have a clique, a group of people, a clique, that take over, they can censor all those people that don't agree with them. So now you have an established religion because now new ideas can't get in there. And that's the status quo today. But see, if you go back to the days of the Greeks as well, you'll find that all these schools, they did the same thing. They threw caca at each other's faces. They treated the other guy, they would laugh at him and say, look at what this guy believes in, and so on. So, we've got a long history in so-called science, where instead of being polite, being civilized, and people are allowed to present their theories without any objections, especially if they have a new theory. I don't even care if it's a flat earther. I don't really care. I don't agree with flat earthers. I don't agree with the electric universe, etherists, or any of those people. But, I think they should be allowed to present their theories, and that you should be allowed to criticize them. And you say, well, but they have all these crank theories, all these idiotic theories. Well, what does quantum mechanics have? They have bigger idiocy still. Well, what does quantum mechanics, what does general relativity have to offer? Just ridiculous garbage. Okay, what do you see today in general relativity? Well, you'll see black holes, dark matter, dark energy, Big Bang, other universes, parallel universes. You see only garbage, just garbage. All of that can be thrown totally in the trash can. None of it survives science. And likewise, in quantum mechanics, you have all these weird notions, that a particle can be at two places at once, that this particle can affect that one without any mediator, between them, physical mediator between them. That you have superposition, you have particles coming from the past, from the future, like tachyons and so on, faster than light, which violates special relativity, but they live with both stories anyways. They say, oh, but we like tachyons because that allows us to get off the planet someday and go to the nearest star. Who knows why? But they allow all these theories, but they don't allow flat earthers, they don't allow ethers, they don't allow, the plasmoids. They should allow all of them. I mean, if we're going to tolerate the garbage of quantum mechanics, we might as well, tolerate them all. And it turns out that there's this fellow, and his name is Jake Barandes. I think that's how you pronounce his name, Barandes or Barandes, something like that. Anyways, he's from Harvard, and I think they're grooming him to be the next Carl Sagan or something along those lines, like the next celebrity for the new generation. The older generation passes by, like Carl Sagan. You don't hear as much also about people like Brian Greene. And now you need the new guys. The new guys have been brainwashed in all these colleges, right? All these universities. And now they get to carry the baton, right, to the next generation. And some of these guys, you have like Hassenfelder and you have Penrose and all these people. And, people say, oh, I like this guy because he's kind of like a dissident. No, none of them are dissident. They were all brainwashed the same garbage. They all believe in quantum mechanics. They all believe in relativity. And within that, they say, well, I'm more like a wave guy. And the other guy say, well, I'm more like a particle guy. And so they get into fights about petty stuff that has nothing to do with anything. There's no differences between any celebrities. A guy like Neil Tyson believes exactly the same garbage as Brian Cox, as Brian Greene, as they all believe in the same nonsense. There is no difference between them because they all accepted, first of all, the quantum atom, which is the planetary atom, and that's the one they use, or the one they've been led to believe is the one that got to be used for ionization and for electricity. That's the one they use, that model. And then they say, well, that's not our model. That's not the real atom. That's, So why did they present that atom of, the planetary atom, the orbiting bead, if that's the one they're going to be using to do their presentation for ionization, electricity, and all this stuff, and quantum jump and so on. So yeah, we have a problem because these people have hogged, the reins of science, you could say, physics, and which is nothing related to science or physics, but they're the people who control what reaches the public, right? And they're the gate, the gatekeepers. Okay, so we have this fellow, Jake Barandes, okay, and who is he? Well, he's some kind of philosopher of physics, physical philosopher. They've got all these billions of categories in mathematical physics that, I don't know why they had to create all these categories. In physics, in general, in science, in real physics, in genuine physics, it's just physics and philosophy. And those are the two branches of science. That's it. There's no more. And within that, you could break it up in a little more, a few more categories, like paleontology or biology or whatever. But the main two categories are physics and philosophy. Never the twain shall meet. And this fellow says that they do meet. He says the following: he says, I do research at the intersection of philosophy and physics. My work has two sides. And he mentions two sides. He says physical philosophy and philosophical physics, whatever nonsense that is. I don't know what he's talking about when he creates these categories. Maybe to make more money. I don't know. And so the question is whether this guy has any knowledge of physics or philosophy. And so what is physical philosophy? It says involves examining what our most successful physical theories tell us about traditional questions in metaphysics and the philosophy of science. I have no idea what this metaphysics is, what philosophy of science is. In real science, in genuine science, there's only physics and philosophy. Okay, there's no such thing as metaphysics or ontology or semantics or philosophy of science. And then you have this other side, is philosophical physics. What is that? It involves using the methodological tools of analytic philosophy to what? Make progress on open problems in physics. Why do we need the word philosophy in there? If you want problems in physics, it's called physics. That's what we solve. We solve problems in physics. And what is physics? Well, you got to explain how this universe works. That's what it is. So in general and genuine science, we only have these two categories. That's it. Science, rational explanations. What are the two branches? One is the rational explanations of causes and mechanisms, and philosophy is the rational explanations of reasons and purposes. We're done. Okay? Scientist is a guy who presents to a crowd and tells them a theory. He explains something. Right? He doesn't describe mathematically. He doesn't do an experiment in front of them. He explains. That's the scientist. Anybody can do an experiment and not understand squat about what he's doing, which was the case of Michael Faraday. He just did experiments. He didn't know what he was doing. Okay, so this fellow, he's a philosophical whatever, physicist or physical philosopher or whatever. Okay, and I like the fact that he says he works on the foundations. I thought he was going to say of physics, but he does say that. Like you can say foundations of physics on the left, but he says he works primarily on quantum mechanics and the metaphysics of causation, which is very interesting because I work on the physics of causation. It's very close to what he does. Okay, but what's the problem with this guy? If he's a physicist, he's a philosopher, hey, better yet, he's got two branches of science. He knows about objects and he knows about people, right? He knows how people behave, etc., or whatever he understands by those two words. Anyways, the point is that I don't care what field he's in. He could be in just strictly physics, or he could be in philosophy according to what he thinks philosophy is. And remember, the Stanford Encyclopedia of Philosophy never defined the word philosophy. Nobody knows what philosophy is. Nobody has defined what physics is. Nobody has defined what science is in a scientific manner. And so we don't have definition for these three words. So, we're going to be running around in circles with people like this Barandes. Anyways, you would think that if he's a physicist, right, and he's also a philosopher, I don't care which base he touches, the word he should be able to define is the word exist. The word real. What does real mean? What is exist? I mean, you would think that that's the first word he's got to learn. I mean, we learned it in the first day of class in physics, in science, right? And he says he's a physicist, warmed the seat for 10 years. He at least has to know what exist means or what real means, right? And here's from the horse's mouth. You can hear it from him directly. Okay, this is what he's got to say. Listen to him carefully on how much he knows about what real is and what exists is.
I don't have a definition of what real means that doesn't involve words that essentially mean the same thing as real. To say something is real is to say that it exists. But what does exist mean? To say that it is real, really there. Some very primordial, primitive notions can be very difficult to define rigorously in a way that isn't logically circular. So for these kinds of notions, and these include things like reality and existence, they are very difficult to define.
Okay, so does this fellow know what exist means, what a real means, what actuality means, reality? I mean, you would think that as a minimum, he should learn that word. He should know what it is. Why? Because physics is the science of existence. Here it is. Physics is the science of existence. He who cannot define the word exists is neither physicist nor philosopher. Okay, so this fellow is neither one of those two. The job of a physicist has always been to tell the audience what exists in the universe and how it works, meaning why it works, right? What causes it to work the way it does, the mechanism. That's what we're interested in. Yet not a single philosopher, physicist, researcher, theologian, or theorist in the last 10,000 years has ever been able to zero in on a definition of strategic word exist. And this is strange because, they had all this time. You got all these philosophers and physicists, and they've been talking for years, for hundreds of years, and not one of them can define the word exist in a way, like he said, where it's circular, where all you have is synonyms. And he says it's so difficult to define. But what's interesting, he's never figured out, as a so-called physicist, so-called philosopher, that this word is so important, and yet nobody has defined it in 10,000 years. It never clicked in his mind that something must be wrong. And so, yeah, you have, not a single textbook of physics, which is the science of existence, right, begins by defining the formidable word exist. And this explains why atheists, theists, and agnostics debate in circles about the existence of God. All of them just use synonyms. And here you see it, atheists, theists, and agnostics argue in circles. Why? Because they never defined the word exist. Not a single one of them knows what exist means, what real means. And yet, again, physics is the science of existence, and unless you define that, you won't know if God exists. You want to know if God exists? Very simple. Define the word exist. That's how simple it is. And what they use all these synonyms that you see at the bottom there, real, reality, actual, actuality, and so on. And you can't use synonyms to define a word because synonym is a circular definition, otherwise known as no definition at all. That's what a synonym is. So you can't use synonyms to define. And these people begin talking. I mean, this guy talks for hours on YouTube, on the internet. Talks for hours about the existence of that, the existence that he uses that word constantly. He wants to know what's real out there. He wants to know how this universe works. And he had never defined the word exist, which is absolutely ridiculous, right? Okay, so this is what we have to say to a fellow like him. And this comes not from me, okay, but a fellow over there in our Rational Science group in Facebook. And he says, don't whine, define. My friend Jeff has that saying, and I stole it from him. I hope he doesn't sue me for plagiarism. Anyways, this fellow doesn't know what exist means. He should not be crying. He should not be whining. He should be defining. And he probably would never, I don't think he has the brains to be able to define any word, let alone the word exist. I mean, and, there are more important words which we have in what we call the foundations of physics, what he says he's an expert at. Foundations of physics, you can't define a word like exist. Okay, so here we have the definition of exist. Okay, there you go. Exist, physical presence. Okay, it's an object that has location. And before you can talk about an object having location, you obviously need to define the word object and the word location. We're not going to define location today, but we do want to quickly say what an object is. And again, that's the other word that no one has ever defined, and not a single textbook of physics begins by defining the word object, and physics cannot be done without objects. So I like to say the definition of the word object destroys all religions. God, you believe in God. Does he exist? Very simple. First of all, we need to know if God is a physical object or is an abstract concept. Who do you pray to? Do you pray to this guy with a magic wand who made the universe? And is made in our image, by the way, so we have a pretty good idea that he's, looks like us more or less. Doesn't look like a cow or like an insect, right? He looks like us. And that's one version of God. The other version is the abstract concept. I mean, is he a spirit? Is he intelligence? Is he love? What is God? Is a concept that you pray to love? That's what's going to get you back into heaven, right? I mean, what is God? First, you got to determine that. And then if you want to know if he exists, well, he's got to have location. So if he's an object, right? If he's a concept, forget it. He can't exist. No concepts are said to exist in physics. And exist is completely dominated by the discipline known as physics. Physics has an exclusive property over the word exist. Nobody else can use it. No philosopher, no historian, no one else can use the word exist. Only a physicist. That belongs exclusively to physics. Okay, so here's the definition of object. What is an object? Object, that which has shape. The only universal property of all objects. An object is not that which you can see. An object is not that which you can touch. An object is that which has shape. An object is not that which is made out of matter. None of those definitions are rational. They're all irrational definitions. I've talked about that in the past. Won't go over that. So this fellow who does Barandes, he does Foundations of Physics, and let's see if they match foundations of physics that we have here. Okay, these are the foundations of physics. Now, which are the definitions you need to do physics. These are the cornerstones, the foundations, right? And we start with the golden principle of physics. Physics requires an object. You just can't do physics without an object. A lot of these people want to do physics with concepts. They have concepts such as field and energy flying around, mass, and they bend time and so on. No, we don't do any of that in physics. Okay, in physics, you have to have an object if you're going to give a physical interpretation, which is what physics is all about. Okay, and so physics requires an object. That's the golden principle. You can't. That's a non-negotiable principle, I like to say. What are the words you need to define? The first word is the word object. You need to know what an object is in physics. Not a single textbook of physics on planet Earth ever define the word object. And you can test me, look it up. Okay, see if you find one book and show it to me where someone said an object is blah, 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 right? Space, that which doesn't have shape. Distance, location, there you see it's a set of distances, and in order to define exist, you need the word object and the word location. It's an object that has location. And then you have motion and a concept, right? So those are the foundations of physics, okay? You need to absolutely define those terms if you're going to do physics, which is all about physical interpretations, about explaining how our universe works, meaning what exists first, and then explaining how it moves. Okay, so what were the problems with this fellow? Well, this fellow, he studied so-called physics, mathematical physics at a university. I think he studied in Harvard. And what was he taught? What did he learn? I mean, and, the main problem with what these people learn, which they learn by rote and never question, is that, light is mediated by particles or waves, subject that we're going to be talking about today. And it never occurred to him, never even crossed his mind to throw away the baby together with the washwater, erase the entire board completely and start all over again. It never occurred to him. He said, oh no, quantum we have to respect because it comes from Niels Bohr. We have to respect relativity, it comes from Einstein. We have to, pay homage to all these people, right? And so he never even questioned any of that. And still to this day, he doesn't question it. That's the issue. And here it is, okay? What they've been taught is that light is some kind of wave. It comes from all these bozos that we had in the 19th and 20th century. And we're saying that none of them hit it on the nose. What they've been looking at for the last 400 years, at least since the days of Robert Hooke, who came up with a wave notion in 1665 in his book Micrographia. He's the first guy that had noticed that there were that light had wave properties. And it never occurred to them that none of these words that they're proposing, like wave, whether it's transverse wave or longitudinal wave, is not a physical object. Wave is not an object. It's a mathematical concept. It never clicked on them in their minds. So they've been working with this thing, and they put it in motion, as you can see it there. And it also travels one way, in one direction. The rope, which is what what they've been looking at really in all these years, a rope that twirls in situ, not only shows you why light is so fast, because torsion is, leaves waves in the dust, biting the dust. Torsion travels very fast, along a rope. Why? Because it's already connected at the other end. Okay, and so all atoms in the universe are physically connected by a rope-like, DNA-like pair of twined threads. Okay, and the torsion of that is what we call light. That's how simple it was all these years. But these people are still, dealing with waves, which are mathematical concepts. Because what is a wave? What is it made out of? Well, it's made out of two fields, right? What is a field? Bunch of numbers in space. That's what they say. It's a value at each point in space. And what is a field made out of? It's made out of vectors. What is a vector? Magnitude and direction. Again, we have The wave is made out of numbers, which are made out of numbers. That's all we have, just a bunch of numbers. And so, yeah, here you can see synthesis of that. The electromagnetic wave has no chance whatsoever in science. We replace it with a rope, with a physical entity. Now we can do a physical interpretation, right? And one of the first things that you can explain right off the bat is why the velocity of light is a constant anywhere between any two atoms, anywhere in the universe, irrespective of the material, the density of the material light goes through. Let me repeat that because some people may not have heard. It doesn't matter what material it goes through. This notion that the mathematician created known as refractive index. I worked with that many years, at AMD when I made wafers. Refractive index is a mathematical concept where they look at the angle. They change the angle of light because they say, okay, when it goes through glass, like SiO2, light hits glass, it turns a corner, it bends, or really it deviates, which should be the correct wording that they should use, because if they're going to be using photons, discrete photons, and even if they use waves, you're talking about deviation. You're not talking about bending. What's bent is the brains between their ears. That's what's bending. They're talking about deflecting. That's what they're talking about. And so, because again, it's one-way travel. And so you're talking about deflection, not about bending, like they say. But with the rope, you can see why. If every atom is connected to every other atom, from one atom to the other atom, it doesn't matter where it is in the universe, what material it belongs to, the torsion of light between those two atoms is always going to be 300,000 kilometers per second. That's it, period. Why? Because C equals frequency times wavelength. Frequency goes up, wavelength has to go down, and vice versa. And then you can see it in a rope. You torque a rope, you make more links, and each link is shorter. You untorque the rope, now each link is longer, and you have fewer links. And that's what that equation is. That is the equation of a rope, not of a wave or whatever, transverse wave or whatever they call it, over there in mathematical physics. So yeah, at least we can explain that. That's one issue that the rope model can explain, which the wave of mathematical physics cannot. And it never occurred to bean brains such as Maxwell that they were dealing with concepts and not with objects, with physical objects. Physics is about physical objects, not about math. It has nothing to do with math. Math has no place in physics because physics is about explaining. Math can only describe, has no power to explain. An equation cannot explain anything, and it cannot tell you what exists out there. For that, you got to use your brain, especially for invisible, intangible stuff out there. Okay, and the other big error is this planetary atom that Niels Bohr and Rutherford came up with, which is a ridiculous thing. Why? Because you have this little bead, the electron, the blue one there. It's negative. We don't know what negative means. We don't know what positive means. But they say negative attracts positive and vice versa. The center of that atom is supposedly positive, the nucleus. And the question is, why doesn't the electron bead fall all the way to the nucleus, the positive nucleus? And that's one problem. The other problem is, why doesn't it spontaneously fly away? Why does it keep falling between energy levels? What is it? The energy level or orbitals, right? And they never explain that. Even to this day, we don't have an explanation from the quantum mechanics of why the electron doesn't fall. In other words, the physical reason. They start going into math. They say, well, you have so much potential here. No. Tell me what wall is there. I need to see the wall that prevents the electron from falling all the way to the nucleus. Likewise, I need to see the wall, whatever wall or whatever object you present. Physics is done with objects, right? You got to tell me what object prevents the electron bead from flying away. Okay, and then you have electricity. What is it? Or ionization? In fact, ionization is electron just comes out of there. Why? Why didn't it come out before it was ionized? Why does this electron bead flow from atom to atom and create this so-called electricity that they teach you in high school and college? And we have no answers to any of those questions. So we don't have physical interpretation. What we have is a bunch of math descriptions of an invisible world that they imagine being mediated by particles, by discrete particles. And what we need to abandon is the discrete particle together with a wave, throw them both in the trash can. Throw the baby away together with a washwater. None of that survives science, logic, or rationality. Okay, so here we have our atom compared to their atom. That's our atom, the rope atom, right? All the ropes converge on our atom. One thread goes to the center, the other thread goes around, builds the electron shell, membrane, or balloon, however you want to see it. It's a ball. It's a ball of yarn. That's what it is. And one thread goes through the center, and that's the proton star, as we call it. So we have a star which is encapsulated within a membrane. These are physical objects. The garbage you see on the left is a mathematical poppycock nonsense, whatever that is, but that's the one that they use even to this day. Okay, so yeah, their version of the atom has no place in science. Okay, and one of the things we can explain with our good old atom is another issue that Einstein was working with, and that's why the speed of light is not added to the speed of the source. You're running around with your car, you turn your headlights on. Do you add the speed of the car to the speed of your light coming out of your headlights? And the answer is no. Light always travels at the same speed, irrespective of the speed of the source. And here you can see why. Because the atom is torquing the rope that's between these two atoms as it slides, as it eats into the threads that go and make up that atom. So you can see the threads moving around and through the atom as it moves through. So it doesn't. So the rope does not have to move. In other words, it's constantly torquing, and the atom is just sliding through it like beads on an abacus. That's all it is. That's why you don't add the speed of the atom to the speed of light. They're two separate entities, and it's like it eats into the two threads that make up the atom. That's the way it works. And so now we can see why light travels so fast, something that the mathematicians cannot explain. They cannot explain the cause, right? We can explain the cause. The other one we can explain, in other words, C equals frequency times wavelength, the inverse relation between frequency and wavelength. And the other thing that we can explain is why the speed of the source is not added to the speed of light. Okay. So we do have some explanations. Do you believe in the theory? Do you believe in my theory? We don't care. Belief belongs to religion. Here we come, we explain, you take it home, you do whatever you want with it. You don't want to believe, no problem. But here what we do is explain. We don't do like the mathematicians do. They say, oh, we've proven. Give me a Nobel because I proved it. No, you don't prove. Prove means you convince someone. That's all proof means. Evidence, verification, all that just means you convince someone. That's got to do with belief. In science, we do not believe. In science, we explain so that someone understands the theory, and then everybody goes home or to their church, and that's when they start believing or disbelieving.